Okay, we're going to keep shifting away from rectangular coordinates and rectangular graphs and going on to these things called polar coordinates. So we've been representing graphs of equations as a collection of points, the x and y coordinates we're used to, on the rectangular coordinate system where x and y represents the directed distances from the coordinate axes to the point. So like x represents how far you go left and right, y represents how far you go up and down. But in this section we're going to be talking about these things called polar coordinates. So to form the polar coordinates, in the plane, we first need to fix the point O, that's O not 0, called the pole or origin. That's why we use the letter O for it. And construct from O an initial ray called the polar axis as shown in figure 10.5, or yeah, 10.59. I don't have that figure labeled as that, but that's where we got that figure from. So again, here's point O. It's kind of like the origin. We have a ray going off this way, going off in that direction. We've got r, which is the directed distance. You can kind of think about it as a radius from your point as if you're drawing a circle. And then theta is your directed angle, starting off here, kind of going in a clockwise direction for this case. Now let's test this out and see how we can figure out, or if we can figure out how to draw these graphs. So we're asked to plot the following points provided the polar graph. So we have r, theta, so that it's kind of like the r is our first coordinate, the theta is your second coordinate, is 2 comma pi over 3. Now taking a look at this graph here kind of looks like that good old unit circle that we might remember from a couple of units ago. We're going to come back to this unit circle in just a little bit. But when we're talking about r and theta, r is really telling you how far away you are from the origin. So taking a look at this, if your origin's here, we're going to say this is 1 away, this is 2 away, and just kind of talking about the 1, 2, 3, 4, those are how big your radius is, how far away it is from the center. So like for this circle here, that whole circle has a radius of 1, this whole circle has a radius of 2, etc., etc. So if we're at the point 2, we're going to go out to that second radius, and then pi over 3, we're going to rotate up to that angle pi over 3 and draw a point there. So that is where point A is. Point B, 3 negative pi over 6. So we're going to go out to a radius of 3 and go down negative pi over 6. Well, kind of putting it into perspective here, if we go up pi over 6, that'd be up here. Down pi over 6, we're just going to go in the opposite direction, so we're going to be down here. So our point B is right there. So our radius of 3, then an angle of negative pi over 6. Point C, we're going to go 3, 11 pi over 6. Now we'll go again out to the third ring. So out to the third ring. And then 11 pi over 6, we're going to go around that. And then, hey, you know, we end up at the exact same spot. So that's both B and C. And you know what? I'm actually going to have us do a fourth point. Let's do r comma theta equals, let's go negative 4 comma pi over 4. Now this one's a little tricky. Negative radii, instead of going to the right, so like if we were to go to positive 4, we'd go 1, 2, 3, 4 over here. But since we're going negative 4, we're going to go 1, 2, 3, 4 to the left. Now the angle measure, pi over 4, we're still going to go in the positive angle direction. So we're going to go counterclockwise pi over 4. So again, we're currently right here. And we're going to go down pi over 4 to 5 pi over 4. So we're going to go from here again. We have a radius of negative 4. We're going to go down pi over 4. I'm actually going to show you another way you can think about that. So another way you can think about it is if you are, I'm going to do a different color for this one. So wait, that's point D. Kind of thinking about a, it's hard to draw in here. This is one of those situations where I definitely wish I was using a whiteboard. But if you were to go to the angle measure first, pi over 4, that's over here. So like this would be pi over 4, 1, pi over 4, 2, pi over 4, 3, pi over 4, 4, pi over 4, 5. Sorry, let me flip that around. It'd be 1 pi over 4, 2 comma pi over 4, 3 comma pi over 4, 4 comma pi over 4, 5 comma pi over 4. So that's the angle measure. This is going out in the positive direction. So if we're facing that direction, if we go to the positive direction, we're going out here. If we're going to go in the negative direction, it'd be still facing that way. We're going to walk backwards. 1, 2, 3, 4 spaces. So again, you can think about it that way as well.